Appreciate it. Well, I want to talk about, well, first of all, thank you so much for everyone who has joined. I really appreciate it. It's a great pleasure to be here, and I hope you're able to hear me fine. Let's get started. Well, I want to talk about a few new cool features in Java, modern Java. And I can't tell you how excited I am in terms of the features that Java has in the recent years. And that's exactly what I'm going to focus on today in this presentation. So let's get started. Well, I want to talk about recent versions of Java in the past few releases and share some excitements I have about some of these things along the way. Well, first of all, one of the nice things is Java is working really hard in terms of how they can reduce the ceremony of the language itself and make it really helpful for developers to use it very fluently. And that's basically the whole idea about the development. Recent changes in Java is to bring about some of those changes into the language. So with that said, let me see if you're able to see my screen actually. So can somebody confirm you're able to see my screen? Looks like it's misbehaving and flipping out. Let me see if you're able to see it now. I apologize for the difficulty here. Is that any better? Can you confirm? Can you see my screen? Excellent. That's my screen. Okay, wonderful. Thank you. First of all, Java has come a long way in terms of bringing in things that reduce ceremony for developers. Well, one of those efforts is, I would like to call it as a smart casting, but a pattern matching with instance of. Let's take a look at an example of what that really provides and see how we can benefit from that as developers. So here is an example of a function called process that I'm calling with a one and a hello. And I use the instance of to check if it's an integer, and then, of course, to check if it's a string, as you can see. But what I want to do is to display, let's say, the length of the string. So I'm going to say length over here. Let's say length is equal to, and we're going to bring in some length in here. And then I'll just say I got a string of length. And then let's go ahead and print out the length itself. But how do I get the length? Well, easily, what I would like to do is to simply say input.length. But you know that would not work because input is an object of type object, reference of type object, so we cannot really dereference it. So one of the things you really have to do, unfortunately, is to take that integer input, and then you have to convert it to a string, the reference, before you can actually use it. Now, of course, once you finish doing this, the compiler is going to be happy to convert the given input to a string object. And then, of course, we can access the length out of that particular object and use it. But what do you call this one? Well, some people call it casting. I call it punishment. And that's what it is. We've been punished over the years by the compiler asking us to do things when the compiler should be working for us rather than we working for the compiler. Well, enough of that. We don't have to do that anymore. So we can simply say in here, length is equal to, for example, a stir.length, where the stir could be a variable, a reference we can introduce as part of this instance of. And as you can see in this case, input instance of string and then stir. Well, not only can you avoid the casting unnecessarily, you can also make use of this very nicely in an if condition as well. If the first half checks the type, the second half or the remaining parts of the condition can really use that variable in scope. And of course, once you leave the block, this variable is no longer in scope, so it's pretty safe to use. So that removes the ceremony in the code, as you can see, pretty nicely. One of the other things that I really am excited about is a switch as an expression. Let's step back for a little bit and think about it. Well, in the past, Java provided switch statements. Now, Java is a language which was created with object-oriented programming, but imperative style of programming in mind. But over the past few years, Java has embraced the functional style of programming. As it turns out, in truly functional programming languages, we have expressions much more than statements. Now, why is it so? Because statements, by definition, don't return anything. As a result, if you want to use a statement, you're going to get into side effects and mutability, which is something we are trying to shy away from. So expressions are superior compared to statements. Well, the good news right now is switches our expressions moving forward. So what are we going to do with expressions? Let's take a look at an example just to illustrate that point. So notice I have a function called process that I'm calling with a bunch of different values in here. Now, what do I want to do within this? Notice in the return, not a statement, but an expression, I'm going to put a little switch right there on the input right over there, as you can see. So now I say return switch input. And once we return the switch input, that is an expression we can do stuff in here. So for example, default over here, and I'm going to simply say whatever, and just return that value of whatever to begin with. But then we can say case one. And if it's a one, we can put a little arrow, and I'm going to return a one, as you can see. But as you notice here, there is an automatic break at the end of that. So we don't just run over the remaining code, which really removes errors and various other side effects we often have. So this is really nice to have. But not only that, you can combine multiple values together as well. For example, 2 or 3, if you will, and you can specify that also in here if you really wanted to. And likewise, if you have a need to put multiple lines of code in there, you certainly can do that as well. So for example, you could simply say here, running some computation, let's say, and of course, in this case, you can then print out return, and you can print out whatever you like to do in here. This is going to be an yield, of course, and we could say 4, for example. So that gives you an idea about how, well, of course, it does require that we spell yield properly. So if I run the code, you can see it does give us the outputs running some computation and 4. So this removes the necessity to mutate variables, introduce garbage variables. But more important, what I'm really excited about this is where it's leading us towards in the future. And that is, it's leading us towards a beautiful pattern matching capability. So I mentioned about auto breaks and multiple matches as well. And you can also have multiple line cases, as we can see. Well, that takes us to text blocks, and I'll be honest about it. I've used text blocks, often known as ear docs in many languages, and still I got excited about the way Java has done it. Why? Well, I'll show you why in just a minute. So Java, of course, in the past had a terrible practice of how we would create multi-line strings, nothing for us to be really proud about. So here is an example of a greet function. And in this case, I'm going to say a string, let's say message is equal to, and I'm going to say this is the first line. And of course, what you would then do is painstakingly write message plus equal to, this is the second line. And we all have written code like this in the past, isn't it? Of course we have. And this is the third line. And then, of course, eventually at the very end, we might return that message back to the caller. Now, we all have written code like this, but nothing to be proud about. And it's not even in multiple lines. We have to put a /n. And this is not something we show to other people. Let's be honest about it. Would you put this on the resume saying that I'm really good at writing plus equals to tie strings together? No, this is what we hide so the world doesn't see it. You don't have to do this anymore. We can write this code with great amount of fluency. So notice I put 3 double quotes right in there. Then we can remove all this fluff around this, and we can simply write that nicely as a multi-line string, as we can see right in there. And then we can eventually end that in the very end and close that out. So as you can see in this case, that becomes really nice. Now, not only that, you can also embed variables into this if you really like to do. For example, comma %s, and then you could simply say, take the string and do a format on it. And then, of course, you can, once you format it, you can put the string in there and tie into it if you really want to do that. Absolutely, you can bring in. You don't have an interpolation capability, but nevertheless, that's pretty darn good. And you can certainly use that nicely in your code without any difficulty at all. Well, but then what excited me about Java is you not only can create multi-line strings, you don't have to do silly escapes in that string. For example, you can go in here and you can say, hey, and then how are you? And you can see in this case, I can even put a double quoted string right in there there without having to perform any escapes in it. So that becomes really nice way to do it. But one of the things that caught my attention was, a few things actually. The first is the smart indentation. So what does a smart indentation provide for us? Notice that Java was really smart. When I run the code, notice there's no indentation in that. So they were smart enough to realize that we most likely did not mean this indentation, and so they got rid of it. But of course, if you want to indent, you can definitely do that, and you can see the indentation appear right there. Similarly, a lot of times we copy and paste XML document, HTML, or JSON data from other sources. And if we do copy and paste, typically we're going to have spaces in the end. And very smartly, they remove the spaces also. And you can see that already in the output, but you're kind of thinking, are we really seeing it? Sure, because notice that little patch doesn't extend. But if you're still not really sure about it, let me absolutely make it clear. If I say replace, let's say, a blank space with a little tilde in here, we can notice where the tilde appears in the code, and you can see the places where the tilde is. Of course, if you really want to preserve the white space, you can certainly do that as well by putting a little /s, as you can see, and you can see that's covering through all the way. So that's an example of how very smartly they handle that as well. So you can have a next line attachment or a blank space being preserved. You could do that as well. And then, of course, you can format the data, like I mentioned, using a formatting capability. And you can use a formatter to do that, or you can use a replace. I just did a replace here, as you can see in this particular example. But you can also go a little further and do a formatted as well. So you can say formatted, for example, in this case. And you could say, in this case, what do you want to format after all? Well, we can take the string, if you will. Oh, let's actually do it on the next line here, if you don't mind. So we could say, in this case, a %s, and I'll come back and talk a little bit more about some of the beautiful things they do behind the scenes as well. So in this case, of course, I'm going to say %s over here, and I can then come in here and say, well, a string dot formatted, and then I can specify the message I would like to format with the name, in this case, the word, of course, that I want to bring in. And we can ask it to really provide that kind of capability as well in terms of formatting it. I'm probably making a mistake in calling the formatted here. So that's on line number 12. Let me just actually call the formatted on the message and see if that is where to be happy with it. So formatted, actually, in this case, anyway, I'm throwing a blank, but let's move on. So you can call the formatted, and you can ask it to format the string and fill it in if you really wanted to. Now that we talked about the text block, what really excited me about this was the smart indentation, along with a few other features I mentioned. Part of the reason for that is, like I mentioned, I've used this in other languages, and I have to say it's a bit annoying to deal with the indentation, but the fact that this can smartly figure this out really made my day when I got introduced to it. Well, the two other features I want to quickly talk about are records and sealed classes as well. So what are really records? Well, records really are useful to implement data classes. That's exactly what they are. They're data classes in other languages. You probably have seen them in languages like Kotlin or Scala case classes and so on. And records are really powerful to represent objects that are carriers of predominantly data. You can put methods into them if you really want to, but the primary motive is to be representation of data. But of course, it also removes ceremony. Even though that's a really nice thing, that's not the real primary intention, is to reduce the noise, but that's something I'll take it. So here's an example. If I run this code, you can see it is providing London at and something. It's not really intelligent in terms of its output. Nevertheless, we wrote a constructor, but we are not done with this. You would probably have to write getters over here. You probably have to write body for the constructor still, which is not completed. Then you probably write the equals method. Then, of course, don't forget the hash code method. Oh, of course, don't forget the toString method. And by the time you're done with all of this, we tend to forget what we were trying to do. Well, the point really in this case is our goal is not to write a lot of code. Our goal is to get the work done. So in that regard, this is a lot of noise we waste our time on. And you may say, oh, Venkat, I never write that. I use a really nice fancy IDE. And before I could blink my eyes, it vomits the code in front of me. Well, then we have to live with that unerasable vomit for a very long time, and we don't have to really do that. Well, the good news here is we can get rid of a lot of those things and simply say record right there. And then we can say in here, we have a double value, which is a latitude, and a double value, which is a longitude as well. And we defined a record. But when you write a record, you have a deal of a buy one, get five free. You got a constructor, you have a toString method, as you can see, it produces a more intelligent output. You also have an equals method, a hash code method given to you also pretty nicely, and a getter also written for each of the properties. So as an example right in here, if I were to say var location is equal to, and then of course I'm going to simply say output location.lat, you can see that the value of the lat is being displayed. That's a getter that got written for us. But not only that, you can say location dot equals, if you will, new location. Let's just copy this over right in here. And notice that that comes back as true because the equals method is implemented. But if I make a slight change, notice it comes back as a false. So it's pretty intelligently written already for matching those properties as well. But not only that, what if you try to go out of this world by putting a 522 in there? Well, that doesn't really make any sense to have a 522. Well, you can perform a nice checking right here by writing the location, and you can say if math.absolute of lat or the greater than 180 or the math dot, let's say, absolute of ln is greater than 180, then you could just pretty much say in here throw new, let's say, illegal argument exception. So let's go ahead and say illegal argument exception and display some error that we can display right in there. So as you can see in this case, we can perform error checking as well in the code to say throw new illegal argument exception and validate that also in the code. If that is something you want to do, you can do pretty nicely. But why am I so excited about records? Well, it's beyond what you just saw here is a reason why I'm really excited about records. And part of the reason for that is, like I said, Java now has data classes, which is records, but they also nicely honor immutability too. And that's one of the nice, icing on the cake, if you will. And you got the get properties, you got the toString method, but a record automatically inherits from a record class internally, so you cannot really inherit from anything. But you can, it's implicitly final, you cannot extend from it also. But you can implement interfaces if you want to, and you can also add a canonical constructor like I showed you. You can add methods if you really want to, that's perfectly fine. But here comes two things that are really charming. First, you can define records within your functions. I always complain, I wish Java had tuples. I will quit complaining from now on because you can use records as tuples and you can define them within functions. So if you're writing a function and you really need a logic of a tuple, quietly create a little record right there and play with it so you can have local records within functions as well. And the other thing that really excites me about records is what's yet to come. Records can be used nicely in pattern matching. So eventually in pattern matching, we're going to see something matching. We're going to see something like this. You may say case, for example, and you may say location, and let's say LA, LO, and where if the data coming in for the pattern matching is a location, then it would pull out. This is the concept of destructuring or deconstruction. So construction or structuring is taking pieces of data and creating an object. This is the opposite to tear up an object into properties. So this will extract the latitude into LA and the longitude into LO. And so we can do extraction of data very nicely with pattern matching in the future. Well, I'm going to wrap this up in the next about 5 minutes I have with one final thing, which is sealed classes. Well, in the past, we had abstract classes, we still do, and abstract classes cannot have direct instances, but they can have derived classes. Final classes, on the other hand, can have instances, but they cannot have derived classes. So put them on a spectrum now. On one side is the abstract classes. You cannot have any derived classes from them. Sorry, you can have as many derived classes as you want from abstract classes. Final classes, on the other hand, cannot have any derived classes. So what if I want something in between? Not any number to zero, but maybe a specific number of child classes, subclasses. Well, this leads to the concept of algebraic data types. And algebraic data types really give us the ability to confine the hierarchy of inheritance. So maybe as a person modeling a system, you want to decide what kind of objects can take its place, what kind of classes can be filling in the hierarchy. There are some benefits to doing it. Better modeling, better control over modeling. You get to decide what the child classes can be. And this also helps in the future with pattern matching as well. When you have a pattern matching, if you have considered all the derived classes of a particular class, you don't need a default. And if a particular new class were introduced in the future in a controlled fashion, you'll get a compilation error to let you know that that particular pattern matching is not sufficient. So it can make the code a lot more reliable, and fail fast during compile time is a good thing as well. So what can we do to benefit from some of this capability? Let's take a look at an example really quickly. So I have a traffic light as an interface with a bunch of classes that implement that interface. Now, if I go to the code over here, you can see that I'm using a traffic light, red light, and that's perfectly fine. But if I were to go back here and say sealed over here, notice the code is still working just fine as you would expect. However, if I were to create a blinking light to implement, let's say, LIGHT, to implement, let's say, in this case, the traffic light, well, notice, even if I were to mark it final, I get an error. Look at the bottom error. It says error class not allowed to extend to sealed class. So that is because the traffic light is only allowed to have these three things in here. Now, in this case, of course, those were defined in the same file, so we were able to get away with it. But what if you really want this in another file? After all, you don't want to pollute a file with a lot of code. Well, that's not a problem. You can go back here and say permits, and the permits for red light and yellow light and green light. But in addition, you can also add a blinking light if you really want to add it. So if you go back over here, you can see that the code is okay now. On the other hand, if I were to go back and remove the blinking light out of this, then of course you can see that you cannot really inherit a blinking light from the traffic light, as you can see. So that gives you an idea about how you can create sealed classes. So in other words, the way the sealed classes work is they're really serving two purposes. One is to define this algebraic data types where we can nicely build a hierarchy. Second, they can be used effectively in pattern matching to make sure all conditions are being met properly. And by default, all the classes in the same file are the only permissible ones. But as a variation, you can list the classes as long as those other classes either are in the same file or they are in another file, but they are in the same module. They are permitted to be inheriting. That's basically what you're seeing in here. And so that is basically the sealed classes that are brand new in Java. And this is something, again, from other languages and computer science concepts, but it's really great to see that come up to and be available in Java. So to summarize what we talked about, some of the cool things in modern Java, pretty darn exciting stuff. I'm absolutely thrilled to see these developments, but also where Java is heading. The two things I'm really looking forward to in the future versions of Java are, one is pattern matching and the other is Project Loom. And I'm absolutely excited to start using them and put them to good use, and also to be able to share that excitement with other developers in the future as well. Well, that's all I have. I hope that was useful. I want to really thank you for taking your time to join. And if there are any last minute questions or comments, I'll be thrilled to answer them. Otherwise, I'm done. And I want to thank everyone for their time, effort, and especially the folks, nice folks at Microsoft, for taking the time and all the wonderful effort they put in to make this happen. Thank you so much. I really appreciate it.
Thank God. Thank you for your time as well. It was, as usual, an amazing talk. I could only see the comments on YouTube and on Twitter, a few tweets that came out like saying, only you can fit this much in 25 minutes. Only, and I was thinking like 5 minutes left and he's going to talk about sealed classes. Okay, let's see how that goes. And you always deliver, man. Thank you so much. You're amazing. You're a great lecturer. You're a great professor. You can teach everyone so very, like, so clean, so straightforward. It's such a blessing to have you here with us.